I'm back with a $10 billion James Webb Space Telescope fraud. And the clip we're going to look at today is just going to make it even more obvious. Bear with me.
Images from the James Webb Space Telescope have been nothing short of spectacular. Every image tells a unique story about some corner of the universe. But there's another story as to how the images are actually created that I really can only just begin to scratch the surface of. It turns out there's an entire team of astronomers whose sole job is to bring those Webb public release images to life. And that team consists of two people. Joe De Pasquale and Elisa Pagan are the two imaging visualization specialists at the Space Telescope Science Institute, and they were gracious enough to give us a master class in how they process different images.
You just want to use your 2D bits file. So let's just pretend I downloaded that. And let's pretend I just downloaded all that stuff. So here I've opened the FITS file, one of the filters, into FITS Liberator, and this is what you see straight from the telescope.
So that's an image, apparently, straight from the telescope. Black and white image, which could come from the ground, could come from a telescope in an aeroplane, something like Sophia. No one can test and verify where this came from. These people get the data, the raw black and white image, and as you're about to see, well, I'll let her tell you.
So as you can see, it doesn't have spectacular color, and you can't even see a lot of detail.
And this is what you see straight from the telescope. So as you can see, it doesn't have spectacular color, and you can't even see a lot of detail.
You have to do something called stretching in order to reveal these details near the dark end of this histogram here. So right now it's in a linear scale, so just as it came out of the telescope, but we can apply different functions to stretch the data in such a way that we're revealing more data, but we're not removing or clipping any data. So we can contain the black points and the white points. So as you can see here, we can start manipulating this and bring out more detail. And then we bring it in to a photo editing software. Either we can use Photoshop, we can use GIMP, which is a free software if anyone wants to use that. We have other means too. We have PixInsight, which is a program that's developed specifically for astrophotography in mind. So it's very precise. Now it's really subjective, and it's really just a matter of bringing everything together, and it's more of a personal choice at this point, since we've sort of addressed all the science behind it. And so this is sort of the end stage where I kind of toned things down even a little bit more because it felt a little too yellow, a little.
So essentially, this is her own interpretation of the black and white image she was given. These people just present their own interpretations of the black and white images, which they've got no idea where it really comes from. They tart those images up with the latest software, and then it gets cited from the James Webb Telescope, capturing these incredible shots from space, when she's just told you it's just her own interpretation of a black and white image.
Too dramatic, and I wanted to feel more spacey, more ethereal, but also still have that and maintain that contrast between the two distinct regions. And yeah, that's how you process an image.
Yeah, that's how you participate in a $10 billion space telescope fraud. Great. Appreciate you letting us know. Bear with me. On our left, Hubble Space Telescope, $9.6 billion since launch. In the middle, James Webb Space Telescope, $10 billion since launch. And then on the right, Jenny on TikTok, on her iPhone, $0. And of course, it's obvious now, having seen what we've seen, not that it was difficult anyway, but they've even told us now at NASA. We look at the comparison between Hubble and James Webb, and take into account what we've seen, it becomes obvious that any improvements between Hubble and James Webb are down to software and computer graphic improvements rather than so-called improvements in space telescopes. They couldn't have made it any more obvious if they tried.